Hey, what's up guys? Welcome to the next video of our simulation series. So first off, I want to show you my simulation base that I wrote for you guys, so you don't have to do a lot of stuff that needs to be done that is very tedious, and it is better for you and it's better for me. Okay, so first off, I want to show you guys what it would look like if it's done. So if I start this, I will get on my console a list of galaxies right here in a moment. Right here. And I can choose one of the galaxies that I want to simulate. Okay, so let's say I choose number 6, which is, or let's say number 4, spiral galaxy, which is the one I showed you before in our presentation. And now a window will show up, and where you can see on the screen that right here's a square, our window, and we're simulating the galaxy. And if I can speed up the simulation by pressing plus that I programmed it in, and as you can see, it is all working fine and well, and we will be doing this as well. Okay, so I want to show you first what those galaxies are, or where I got that information from. Hold on. Okay, so right here there's a folder called samples, and in this there are a lot of text files, and those text files I actually got from the Princeton site. Right, I want to show you the Princeton site too. So if you have any questions or information you want to know about, you can go to Princeton's site here. They've got the whole package. Either it's very detailed, and you can read about it if there's things you don't understand. So I really suggest you read this if you don't understand. Otherwise, I'll carry on. So Princeton offers those text files which contain information about the simulation. So let's take a look at the structure of the first one. So right here at the first line, there's a number which represents the number of bodies in that simulation, in that universe. Okay, for us it doesn't really matter, since arrays in Swift don't have a limit, so it doesn't matter. Maybe it's fine if you want to check if you correctly imported all the files, but it's whatever. Okay, the second line is the radius of our universe. We will be scaling our window to the size of the universe by using this radius, so we can actually convert all those bodies into positions that we draw on our window. Okay, so, and all the other lines after that are the bodies themselves. So the first number here is the x position, the second one is the y position, the initial positions. The third number here is the initial x velocity, and the fourth number is the initial y velocity of that particular body. And this right here, the fifth number, is the mass. Okay, and as you can see, the last 3 numbers are just RGB, which represent the number, the color of the body that we can draw it with. Okay, so let's start off with the view controller. As you can see here, there's nothing special. What I did here is I added this monitor for monitoring keyboard events. So if we press plus and Y, we can configure it to do something when we press something. This is useful for just showing or for speeding up simulation, or showing those squares that I've seen in the presentation before, and so on. Okay, so nothing crazy here. The main thing that's actually being done is in the simulation class that I've specified here, which with the function start. So let's take a look at that. Okay, so a lot of stuff going on here. I want to go from top to bottom to give you an idea what it is. So G is the gravitational constant that I've mentioned before, that is a part of the Newton equation for force calculation. Okay, radius, it's clear what the radius is. dt is the delta time, which, just in simple terms, if you increase this, you increase the simulation of the simulation speed, because the number of the velocity and such is very marginable in proportion to their real sizes. So we have to speed up a little bit, so it makes so we don't stare at the screen for hours. Okay, so DrawSpace is a singleton that I wrote. I will check it out in a few minutes. Simulation view is the view. It's simple. It's just a view that is that lies on top of our view controller. It's nothing crazy. The simulation view, we just draw all the things on here. Okay, so start. So now it gets interesting. So we've got a function called read galaxies. Okay, so this read galaxy here, it just takes a look at our bundle and searches for text files, and it filters them to show here as an option, right? So these read galaxies will just return all those text files as strings without the .txt at the end. That's it. So right here we say, okay, which galaxy would you like to choose, and then you choose with as the index, the choice, and then you just call the create galaxy function with the galaxy file string. And what this does is, now that I've explained to you what it is, right, it just converts all those things into objects for us. So all those lines will be celestial body objects, and this right here will be the radius of our universe. Okay, so right here, so the first one is the radius. We can ignore the line on 0, index 0, because it doesn't really matter for us. In other languages, you would need that first line to initialize an array of size, whatever, of the size that it specifies. But here in Swift, it doesn't matter. We just use it, and it, yeah. Okay, so here we go through all the lines that are where the index is bigger than 1. That means we just go over every celestial body, and then we just convert it all to, the types that are appropriate. And then we create a new object of body, so celestial body, and then we append it to our celestial bodies array and return it at the end. Okay, if any errors come up, we'll just return an array of nothing, so nothing too crazy here. So nothing is being done right now. This is just the base I want to build upon. So let's take the next thing here. So DrawSpace, so this is a special class because this is our bread and butter for the drawing here. It's a small class that I wrote, but first I want to give you an idea of what it is. So set rect here and set x scale. So as you can see, we set the rectangle for the drawing space to the frame of our simulation view, which is just the window frame, whatever. And we set the scale to minus radius and radius. So that means that the center is 0, 0 of our universe, right? And then we're in the dead center of our window. But the radius may be a million whatever, right? It's a big number, and we can't draw that big number onto our window that is only 600 pixels wide and 600 pixels high in height, right? So we have to scale those numbers to our 600 by 600. Okay, so let's take a look at how we do this. So right here, there's I will post it in the description too, but this is a very helpful link. I will open it, that shows you how to normalize data to a range. Okay, so this right here, this function, this equation here, shows you how to normalize a data to a range. So x right here would be our input, yes, would be our input scale, which is our whatever we just want to put in x or y value, whatever. And min is our minimum range, which is our minus radius, and max is our maximum range, which is radius. And you can see that I use this concept right here for scaling, right? So this function returns a scaled x value. So if you have a position, an x position of 1 million, for example, this function will scale this 1 million to the correct correct proportions of the window. So 600 by 600, right? So for example, 1 million will be, I don't know, just a random number, will be 300 in our window scale. Okay, you can take a look at it. The same thing, the thing here, y max plus y, this is a little tricky, but basically it's the same concept, just for y, for the y-axis. And this right here is a scaled factor for the height, because if we want to draw squares, we also want to draw the length, scale the length, right? So we can't draw a square of 1 million by 1 million. Doesn't work that way. Okay, so that's it here, and I've set up a few 3 drawing functions where you can draw a point, a square, and a line. Okay, and you can call those from anywhere, but sorry, not from not you can call them from everywhere. You should call them from simulation view. As you see here, I've already did something there, but this should be it for this class. You can take a look at it. If you want to change something, you can do it. The line width, square line width, the line width here, the point size, you can all change it globally via those parameters, okay, but via those variables. Okay, so let's take a look at the next one, which is the celestial body. This is just for simple importing the data, just the most basic class that you need to get started. It's nothing complicated here. We just got a equatable so we can compare bodies for later on. The quad tree is also very simple right now. So initially the quad tree will have a bounding box, which is a square, and the initial bounding box of the root is the window itself, right? Because that's the topmost node that we have. And we've got 4 child nodes. I called them southwest, northwest, southeast, and northeast because that's what they represent in our space. The top left square, south left southwest square, northwest square, southeast square, northeast square. Okay, and body here is our body that will want to insert. And the pseudo body, I call this pseudo body because it's not really a body, but this pseudo body will act as the center of mass that I've mentioned before. And why I did this as a celestial body is because I want to do calculations on it, but not write any extra functions, whatever. So we just treat it as a body, but it's not really a body. Okay, and this might be confusing, maybe. Why is leaf to return southwest equals to nil? Well, in our implementation we will have subtrees, or 4 subtrees or no subtrees, right? If a node has subtrees, it will have all subtrees, but in those subtrees there might not be a body, but there will still be 4 subtrees. So there's either 4 or nothing. So that's why you can also say northeast or southeast, doesn't matter. If one of those is not there, then, or if one of those is nil, then that's a leaf. Okay, so lastly, I want to show you very quickly the vector class that is also very essential to for our simulation. There's a couple just fundamental operations divided by times, minus, plus. Normalize and the length, maybe you should look at that. How do you do this? Basically, for normalizing a vector, you calculate the length and then you divide all the coefficients inside that vector by that length, and that's the new normalized vector. Okay, and the distance here, that's clear. How you do this, you secure Euclidean distance, and right here you can draw. So this is just this is just inside the draw. We can draw inside the vector here. We can call it, if you have a vector, you can call draw point and draw square. And then we have just some conditions that will return true or false, greater or equal, less or equal, all basic stuff, and also an equatable to see if two vectors are the same. Okay, so that's the base for you guys to start this simulation. I will continue in the next video. We will do some basic drawing and so on, just to give you a feel of what it looks like and how to work with this framework or base. And yeah, if you have any questions or any topics you want me to cover, then please just let me know. Otherwise, thank you for watching, and I will see you in the next video. Bye bye.